So welcome to the new academic year, and today I think only two of you. So sign the attendance. We hope to grow this number. I mean, we hope that the number of students will increase, and let's see. This is your first lecture or first lecture, very first lecture for the academic year? Oh, wonderful. Okay, so my name is UDAYS. And I'll be teaching you physics. So, are the lectures started at your school already?
No, actually, our results are about to come on 29,
Right.
and it will start from 30.
Not of it. Just keep it. Okay, so chapter 1 is measurements and experimentation. Experimentation. So let's understand what is physics. So from this year, science is split into physics, chemistry, mathematics. Sorry, biology.
Actually, it was stated in 6th.
Yeah, in CBSE it is. In fact, it is still science till 9th and 10th. But for you, I think it is split since 6th. So since you already are learning about physics, any idea what is physics? What does it deal with?
It is measurements and experiments.
Yes, exactly. So it deals with study of physical quantities. Okay. And basically, it is an experimental science. Okay, so a lot of experiments are also conducted while studying physics. So it is experimental science. So in experimental science, we will need to deal with many physical quantities. Okay. So how do we express physical quantities? So we'll have to be able to specifically express physical quantities. So to express physical quantities, we require units. Yes. To express physical quantities, we require units. Now, this is very crude. As we go forward, I'll explain it even further. So, for example, you're familiar. So, let's say, so what are physical quantities like length, mass, time? Okay. So, anything which can be measured, right, is a physical quantity. So, how do we express length as, say, 10 meter, right? Or 100 meter. So the first thing is called as magnitude, the value. Okay, so this is how we express a physical quantity. We give a magnitude or value of it. And then the second thing is unit. What is a unit? It is a standard reference. Okay, it is a standard reference. Right? So any physical quantity if you take, so if you say mass, you say 10 kg, 100 kg, right? So you have a value and a unit. This is our physical measured value of a physical quantity is written like this, 2 parts. Okay. So there is a definition. So what is a unit?
It is the standard reference to measure something.
Physical quantity of the same type. Okay. We need a standard or a constant reference, okay, to measure the physical quantity of same type. When we say measure means what? Compare. Like if there are two lengths, how do we tell which is bigger, which is smaller? So we need to measure things just to compare amongst the same type of quantity. Okay. Is that clear? So a unit is required. Same type of to compare. Same type of physical quantity. Okay, so these are concept notes. These are not exact definition. This is for you to capture why we need unit. So basically, why we need unit to compare same type of physical quantities. Okay, so then what is unit? Exact definition. So it is the quantity of a constant magnitude which is used to measure the magnitude of a given quantities of the same kind. Now, with definition, you have to just it off. But hope you got the meaning. Is it clear? Okay, so you write the definition. This give you attendance sheet. Attendance sheet. So both the things are nearly same. Yeah. Physical quantities are same. So any questions? Wow, what are physical quantities and what is unit? Why we need them? Okay. Now let's understand what are the different types of physical quantities. Types of types of units. So there are two types. One is fundamental units. Okay? And the second one is called as derived units. Fundamental units and derived units. So what are fundamental units? These are independent units. Okay, these are independent units. Whereas what are derived units? They are dependent on fundamental. So these units are, I'll give you an example. On fundamental units. These units are dependent on fundamental. So what are the examples? So let me list the physical quantity and its units. So there are 7 types of fundamental physical quantities, and their units are called fundamental units. Okay. So what are those fundamental physical quantities? They are also called as fundamental or basic units. So what are fundamental quantities? So length, mass, time. This is something you come across it every day, right? In our day-to-day life, these 3 are the most used. Then temperature, is it there? This is also like every day we use it. Then what else?
Capacity.
Capacity. Oh, we'll come to it. We'll come to it. Capacity as in volume units. Okay, that's right. Because what is volume? Length into length into length. So length, it depends on length. It is length. Anything else? Luminous intensity. Luminous. The light. Luminous intensity. A more brighter light will have more lumen. Okay, that is luminous intensity. So before that, let's go like this. Current, electric current. Then you have luminous intensity. Seventh is amount of substance. I'll explain you about this. Yeah. What is its unit? Now let's write the units. Okay. So what is this unit? Fundamental unit. The units of fundamental quantity is fundamental units. Okay. Fundamental units. So what is the unit of length? Meter. And what is its symbol? So when you write full, it is meter. Always written is lowercase. Always written in lowercase, and the symbol is small m. Okay. So this is how you write the units. What is mass? Kilogram. Yeah. When you write full, it is written like this, and then it is kg. What about time?
Second.
Yeah. Second. And small s. What about temperature? It is
Kelvin.
Kelvin. Written in small k, small letters, and this will be capital K. So whenever the name of the unit is after the name of the scientist, then the symbol of unit is capital letter of its initial. Okay, so Kelvin, capital. Okay. So that is temperature. What about electric current? Ampere. Very good. Ampere is also a name. Therefore, what is the capital A? Okay. Luminous intensity. What is luminous intensity? Candela. Candela.
It is denoted by C. Capital C.
No, that is a word. CD, small c and d. Small c and d, yes. Candela. CD. Amount of substance. So when you are dealing with at atomic level in the microscopic world, then you don't deal with one or two atoms. You deal with a large number of atoms. So like in the real world, we deal with some group of quantities like dozen. So always a 12 quantity of same type, make a dozen of that quantity. Likewise for atoms, etc., we use a quantity called mole, MOLE. Okay, and its symbol is MOL. And how many quantities make one mole? So it is 6.022 into 10 raised to 23. It's a large number. So sometimes it is written 6.02 only. That's okay. So these many quantities make one mole. Okay. So you'll come across these things again and again, right? So this is all in fundamental quantities. In fundamental quantity, there are two supplementary quantities also. They call supplementary or complementary, two more. So under fundamental quantities, two complementary quantities. You get used to the way I write N and E. Okay. So complementary quantities. These are complementary fundamental quantities. Which is angle, which is plane angle and solid angle. All these, like what is solid angle on solid angle, you will learn in 11th standard. Okay. Then, so how is angle measured? Any idea? Degree, right? But what we are dealing with is SI units. I'll explain what is when I say what are the different system of units. So these are all SI units. Everything that you're going to learn is in SI units, which stands for Système Internationale. That's the acronym for it. It's a French term. So, what is the unit of it? Radian. Okay. And what is this? Radian is written as rad, RAD. And this is written as steradian. Okay. But I don't think you have it in this standard anyway. STR. In your book, it says RD only. So NCRT will have RD. Okay, so this is extra. I don't think any question will be asked on this. Since it is given in your textbook, I thought I'll cover it. Right. Now, what are derived units? With this, we have covered all fundamental units. And mostly, you will be dealing with 1 to 5 and 7. 6 also, you won't get any. Huh? So, in this year and next year, you'll be dealing with those units in terms of fundamental quantities and plane. Okay. So, degree as well as radian, what is their interconversion, everything will be taught. Right. Okay. So, any questions still? Is it okay? Am I going too fast, slow? What are derived quantities? These units are dependent on fundamental units. So, what are the examples? Volume. So, volume. Because what is volume? Length into breadth into height. So, what is the unit of volume? L cube. Right? So, volume is length into breadth. Can I write LBH? Will you understand? Okay. L into B into H. And all are length only. So, therefore, what is the unit? Meter cube. Meter into meter into meter will be meter cube or cubic meter. Okay. Any other derived quantity? Speed? Yes. What is speed? Time. Distance upon time. So this is distance on time. So from the formula you will get the unit. So this is a derived because it depends on fundamental unit length. What about this? What is the unit of distance? Distance is measured in meter. Distance is length. Yeah. And what is time? Seconds. So this is meter upon second. How do we write it? Or we can write it like this. Meter per second or meter per second, like this. Okay, these are different expression, all mean one and the same thing. Okay, algebra. Okay, and all those power expressions. All right, then have you studied about acceleration? A little. Okay, I'll leave that. What else? Momentum? No. Okay. Work? Okay. What is work? So it is defined as force into displacement. Okay. Now, displacement is distance in a given direction. So this is the vector quantity, distance is scalar quantity. Scalar and vector has it been introduced? Okay, it will be taught in this year, you will come to know. Okay. So as of now, you just understand distance is a scalar quantity, which means it only has magnitude. Whereas displacement is a vector quantity, which has both what? Magnitude and direction. Unit to distance also 5 meter. So that is magnitude, the value, and unit, right? But what about displacement? It is a distance in a particular direction. So you need knowledge of direction also. Like time, it is a scalar quantity. We don't need to define direction of time to describe it or to express it. I say 5 seconds. I don't say 5 seconds in each direction. Okay. So mass, here also we don't need sense of direction, right? So those quantities which can purely be expressed as magnitude without the knowledge of its direction are called scalar quantity. Okay, scalar. So this is the definition of work. Now what is force? Now force is mass into acceleration. Mass into acceleration. So, but you don't know acceleration. That's why I was into acceleration. Into displacement. Displacement. Acceleration is velocity upon time. Velocity is displacement upon time. It's a very big definition, right? So, but it's a good example. So I'm continuing here. So therefore, work is equal to. So this is how a derived unit is found. So mass, acceleration is velocity upon time into displacement. Because once you understand, then it becomes very easy. Then what is velocity? Displacement upon time. So it will become displacement upon time into time square. Got it? So mass into displacement upon time into time is previous one into displacement. Okay, so now everything is now fundamental quantity. So what is the unit of work then? So work is depending upon these fundamental quantities: mass, displacement, and time. Now replace the unit. So this becomes mass is kg. Kg is small k and g. While writing it in a sound, so kg into meter into meter. So unit of displacement and distance is same, both are length only. Just here you have to specify direction, but while writing unit, no need to write the direction. Divided by second into second. So what is the unit now? You have kg meter square per. Okay, this is the unit of work, and in short it will be called as joule. Now what is, so if I want only the unit of force, so let me write unit of force kg meter per. This will be unit of force. Okay, because initially we had force into displacement, so kg meter per second square. So write it like this: kg meter. This is the unit of force into meter. Okay. This has got a special name. We call it Newton. Yeah. Unit of force is Newton, which is this kg meter per second square. So this is equal to Newton. So since you're familiar with Newton, I thought I'll do it this way. Okay. And Newton meter is also called as joule. When Newton meter or joule. Same thing. So now you understand how it unfolds. Okay, it's very simple. You have to go, but you need to know the definitions, and all these definitions will come in the second chapter, motion chapter. Okay, so you're now prepared to take that chapter easy. All right. So any question till here? We just completed the fundamental units and derived units. So take 1 minute to basically go through what we have captured till here, covered till here. Yeah. Okay, let's proceed. We said unit of length is meter. What is a meter? That is the question. Which length we call as meter? Let's say this is 1 meter, let us say. Then this book is almost 2 million. This is how we compare with, so this is a standard reference. So meter has to be fixed. Right? So what is that meter? Right? So we have to agree, okay, this much length is a meter. And it has to be obeyed all over the world. So that a meter in India, okay, is same as meter in UK or US or anywhere. It's a standard. This is the meaning of standard reference. So we all will agree that this length is meter. So who decides all this? So there is a Bureau of. Now, I'm very bad at spellings. What is the spelling of bureau? It has this. One second. Bureau. BUREAU. Okay. BU. This is Bureau. Bureau of Weights and Measures. So every country has it's a government regulated body, has a Bureau of Weights and Measures, which keep a track of standards. Okay, so that nobody does a cheating. When you go to a shop to buy 2 kgs, so that 2 kgs in every shop should be same. Okay, so it is controlled by this agency. So every country has a bureau, and there is an international body. So that is called International Bureau of International.
The headquarters is located somewhere.
So it is like a conference, like it happened, the one which is mentioned in the book happened in France, Sevres. Okay. Sevres or something at France. So International Bureau of Weights and Measures. This conference happened at Sevres, I think in '69. Okay, so it keeps happening in different places across the globe, right?
So there is some headquarters or something like that, or
Some European country, I think it's not like headquarters. Now it happens in the form of conference. Like in our country, G20 meeting is happening. Okay, so it keeps changing places so that no one country gets like supreme power. It's like that. Okay, so for the sake of convenience, yes, okay, it is registered, some headquarter will be, but that's insignificant. Okay, what is important is what all the member countries agreed upon. So in this conference, India also participated, let's say, or some prominent countries were called. So not every Tom, Dick and Harry will be called. Important people will be called. Okay, and whatever they decide will be applicable to the whole world. Okay? So they decide what is a meter, right? So I'll cover that. But before that, let me give you a brief on what are the system of units. Right. So old days we used to follow CGS system. CGS system. Or French system. Okay. So basically, the basic quantities, how the units of basic quantities, length, mass, and time. Okay, that is how it was defined. So what are the basic quantities? Length, mass, and time. So let me write it vertically. Length, mass, and time. Like this. So in CGS system, length was measured in centimeter. Mass was measured in gram. And time was measured in second. Okay. So that was CGS system. Then we had the British system, which is called as foot, pound, and second system. FP is on British system. So in British system, the length was measured as foot, mass as pound, and this is S. Okay. Then you had the metric system or MKS system. It is also called as yes. S is second, yes. Time. So length, mass, and time everywhere. These quantities, how they were measured in different systems. In CGS, it was centimeter gram second.
Second
So the right
second did change.
no, second is second everywhere. Huh? So it is called metric system. So how is length measured in metric system? Length is measured as meter. Same as like small m. Right? So you can take the symbols also. FT is for foot. Pound is small lb. LB. Okay, this is L. Small L and B. S is second. Second is same. S. So this is meter. Then K is for kilogram. This is kg. And second. Okay. But like I told you, these are all old system. So then you have to convert from one unit to other. Like different countries were following different system of units. Then converting scientific data, it became a challenge. So then it was agreed upon in which year? It is only for historical, just think 60, I think, 1960. But there are conference which has happened as late as 19, I think. Sorry, 2019. 20th May 2019. Okay. But then we'll not go into it, and you're not expected to remember which date what conference happened. Right now, we'll follow this broad system. So don't get bogged down. Even while you read, this chapter is little abstract. To start a chapter with this kind of a chapter, sometimes you may get lost. So don't worry about it at all. Only the first part looks very abstract, but simple things will. Okay, so don't worry about the numbers too much. This is just for history's sake. But what we follow today is SI units. Because there are so many units, you go crazy, keeping track of everything. So to simplify all that, we now follow only SI units. Okay, now everybody follows this unit. This is the historical perspective. So SI unit, I've already told you, right? The seven fundamental units and 2 complementary, so total 9 fundamental. Everything else is derived. Okay? So you have to only remember these 9. Usme se you have to remember only 3, 4. So relax. Any questions? Now let's discuss the choice of the unit. The unit like meter, kg, and second, right? So what kind of a value should be chosen as a reference? Okay. So first is it should be convenient. Right? So like a meter scale, it's convenient. or a kg, it's convenient. Okay, so that convenience of use, so it should be convenient, right? Second, it should remain constant with space and time. Okay? Like if you have a meter rod in India this much, if you go to desert, it should not expand. Okay, so it should be the same length, whether irrespective of wherever you are. Now, at the same place, this year the rod was this long. Next year it's not shorten or fixed. Third, it should not be ambiguous. Ambiguous. Ambiguous means confusing. It should not be confusing. Right? Ambiguous. Should not be ambiguous. Yes. So if what it means is if you have a scale, the calibration should be clear, easily readable. With usage, wear and tear, sometimes the initial part wears off. So time to change. So how can you change? It should be easily reproducible. Right? So it should be easily reproducible. So that, why this? So that you don't have any challenge in measurement. Is there any point which is not clear? Okay. So far, so good. We have 15 more minutes. I think I'll be able to now define the standard. What is 1 meter? Then what is 1 kg? And what is 1 second? Okay. And after that, I think we'll close the video. These 4 things clear? Questions are asked here. Then some rules in how we will express it. Rules for writing units. So I have already explained that all unit symbols
Should be the lowercase.
Yes.
And after if there is it is after a side step, it should be the capital.
Yes, symbols are in lowercase. Except so except is the name of the it is after the name of the scientist. So you can rephrase while going through the book. I hope you understood what I mean. Right? So example. So kilogram, all the full form is written in lowercase. Whether irrespective of whether it is the name of a scientist or not. So kilogram is written like this, and symbol is written as small k. Okay. Next, if the name of scientist is Newton. So when you write the full form, you write it like this. But you express as unit, you write capital N. Clear? This is how you will. And for derived units like Newton meter, so there will be a space in between or a dot. Okay. So this is the rule for derived units. It's separated. By dot or space. Okay, example. So there is a space, Newton meter. Or you will write so these are some rules for writing units. I think this is enough. There could be more. You read and then come back. If I cover everything, maybe like little overwhelming. Till here, have you understood everything?
Yes. Yes, sir.
Have you brought your books? Just open. Selina, you follow me?
Actually, sir, we have not received the book yet.
You mean textbook you don't have?
Yes.
But do you have these volumes?
Yeah.
Okay, okay. So come to units of length. Units of first is length. So how do we define length? So it is defined in terms of how much distance the light travels in this fraction of a second. It's a very small instance of time. 458 of a second. So what is that? Distance covered by light. Right. In. So what is this number? Any idea? So what is speed of light? So how do we get? So distance is. What is distance? Speed of light into time. Speed. Into time. This is how it is. Okay. So this is what it is. What is this number equivalent to? This number is equivalent to 3 into 10 raised to 8. Check this out. 1, 2, 3, 4, 5, 6, 7, 8. Round it off. Okay. So this will be 3 into 10 raised to 8. So, so how much distance the light travels in this much fraction? So if I substitute 1 by t into t, then you'll get 1 meter. How much is time? This much. Right? So speed of light is 3 into 10 raised to 8. Into how much is time? 1 by 3 into 10 raised to 8. So this gets cancelled, and this is what you get as 1 meter. So this is distance. So how much is 1 meter? Distance traveled by light in this much time. Clear? So, and you are not expected to memorize it. Nobody is going to ask unless your teacher is too crazy. Okay, even in 11th, we don't expect student to memorize this. This is just for knowledge sake. Okay. So, what is 1 meter? You understood?
Yes.
And then, since the speed of light is constant, so this becomes a constant or standard reference. Now, second is unit of mass. So, mass, that is what is 1 kilogram. That's what we want to know. So this is a more recent definition. Initially, that 1960 conference, they had one reference rod made up of platinum and iridium alloy. Okay, like in museums, you will have something, right? So it's a platinum, iridium alloy. So in good old days, this was kept there. And all country, because it should be easily reproducible. So they produce, let's say 200, 250 of such rod and distributed to all country. And at a country level, they cloned so many and gave it to all shopkeepers. So in old days, you were not born. We used to have one rod. Up nahi hai वैसे. ठीक है? But it is discarded. So this is now accepted, adopted. Like I said, the conference keep happening. So more recent is this. Okay. Likewise, there was a prototype. It's called prototype. Okay. Prototype. Like one sample piece is kept and everybody has the clone of it. So if there is, in case of doubt, you have to bring that and compare it with it. Okay. So that's what. So likewise, what was 1 kg? It was a block of platinum iridium. It's a cylindrical block. And whatever was, how much ever weight it had, that was taken, whatever was its mass was taken as 1 kg. Got it? So this is a platinum iridium alloy. Read it in your volume. What is it? 1 kg is defined as the mass of a cylindrical piece of platinum iridium alloy kept in International Bureau of Weights and Measures at Sevres in Paris. So that is what it is. But now it is defined differently. You will read in your book. It is defined in terms of Planck's constant. Now that is very cryptic. Right now you will not understand what is it because you don't know what is Planck's constant. Okay, but in your book that term is given. So it's okay. Just read it and forget. That's not to be remembered. Is it clear?
Yes, sir.
Likewise, read what is a second. Big numbers. Huh? So I guarantee you'll not understand it right now because for that you have to be familiar with atomic structure and how the the waves are radiated, the energy radiations come out. So what happens? So we are learning the unit of time, which is 1 second. So what duration we call as 1 second? Now how do we measure time? For that we need something which repeats itself after a fixed interval, like a pendulum of a clock. Okay, so when it goes from here to here, we know it is 1 second. When it comes back, it is another 1 second. And it repeats. So we keep counting the seconds, right? But what is 1 second? So basically, it is today we have a standard clock, which is atomic clock. This is unheard of for you. It is based on cesium. Cesium atomic clock. Okay. Based on Cesium is a element, one of the element. So what of cesium? See what happens, you will learn in higher standard. So in atom, there are various energy levels. Okay. So at the center you have the nucleus and it is surrounded by various shells in which the electron rotates. So whenever this electron jumps from higher to lower level, it radiates energy. Whenever it absorbs energy, the electron jumps from lower level to higher level. So jumping of electrons between levels, okay. So depending upon how it is transiting from higher to lower, it will radiate energy. Lower to higher, it will absorb energy. Okay. So whenever it is radiating energy, right, it radiates it in the form of waves.
Higher to lower.
Higher to lower when it jumps. See, when there is a hot substance, after some time it will cool down, means it radiated. Okay, but if it is an ice block, it will melt because it has absorbed energy. You understand? The process is different. So when it comes from higher temperature to lower temperature, it radiated the energy. So this is also called de-excitation. So now you read the definition. It is the time interval of blah 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 periods of a specified energy change in cesium-133 atom. Now it is not a complete definition. In your book, you'll find that in a hyper fine level. So every level has got an energy associated. So upper level has a higher energy, lower has a less. So there is a difference. When it jumps from higher to level, higher to lower, that much difference of energy is radiated. Okay. And how it is radiated? In the form of wave. Now, what do waves have? Waves have cycle. Can you see? It is repeating itself in a fixed interval. So one of this interval from here to here is called a period. What is called period, time period. The time taken to complete one cycle is called one time period. Okay? These many periods. 1 second. I imagine how precise it is. Okay, and since it is the characteristic of an atom or element, it is constant. Okay, because every element has a fixed state. It's not going to change its state. So that's how precise this measurement of 1 second is.
How does they have taken out such precise?
So you won't understand that in 9th standard. That's like too fundamental. Subject of research. Like if you continue to study physics, and in physics, if you choose this topic to study, then you'll understand. Okay. So it's very, very too fundamental to be discussed at this level. Right? But do you have some idea now what it is?
Yes.
So cesium-133, it's not only cesium-133. So there is a concept of isotopes, like one element itself is available in nature in different forms. Like hydrogen, 3 forms are available. You studied about it. So what are the forms of hydrogens? They are called isotopes. Protium, deuterium and tritium. Got it? So it is hydrogen only, but in different forms. Okay. So likewise, cesium-130. So I think we'll stop here. It's 7:30 already. All right. So yeah, we have covered quite a few. You can go to the root diagram. We have covered till here, units of time. First page. Okay, in the next class, we'll begin with least count and the interesting thing starts there. So go home and try to read it and also try to get your textbook. You'll be provided the textbook by school?
29.
By school?
Yeah.
Okay. Okay, I'll see you in the next class. Thank you. You might be having one more lecture, right?
Yes, sir.
Okay.